So in this video, we're going to take a look at everybody's favorite feature, vMotion, where we can take running live virtual machines and move them around while they're still live and continuing to function. So it's a very blockbuster feature with lots of really interesting implications for how we can do things. We'll talk more about things like the distributed resource scheduler in a later video, but we'll talk here about what we need to do to get vMotion working. We'll understand a little bit about what it is and what it takes and how we can actually do it, which is really very easy to do. But we'll take a look at the dependencies. We'll talk about how we can and what the limits are of doing multiple vMotions at the same time. We'll also talk about some of the new support for vMotion in more complex networks, and we'll talk about TCP/IP stacks and then take a look at the demo. So as for what vMotion is really all about, like I said, it's about taking running workloads and moving them to different hardware, from a host perspective, or to different storage and, from a storage perspective. And this is really one of the main things that you're buying vSphere for. This is pretty much the showcase feature, the thing that really made virtualization super exciting and super interesting. And the ability to take a virtual machine and move it to different hardware is very interesting from a lifecycle management perspective. So we can do vMotion, which is what we would typically call migration between hosts. And we can do that now without shared storage, although this used to require shared storage if we're using the vSphere web client. We can also do storage vMotion, which is migrating a running virtual machine between data stores. Two data stores that the same host is connected to, whether there's other hosts or not, is really pretty irrelevant. Or yeah, we could do both, a vMotion without shared storage, which is effectively a host vMotion and storage vMotion at the same time. You can only do this in the web client. How vMotion works is pretty interesting. I mean, from storage vMotion's perspective, it's actually pretty much the same thing as doing a snapshot, although you're doing a snapshot across the network. What we get with copy on write is the ability to write it to both sides of the transfer simultaneously. So it's really reasonably easy for the local machine, the currently live running virtual machine on a particular host, to maintain its activity while we eventually in the background synchronize that over to another host and eventually, or to another data store anyway, in the case of storage vMotion, and then eventually transfer control between them. Now, when we do that, running a virtual machine across to another host completely, that becomes a little bit different and is certainly a lot more complicated, although fundamentally is not really that different in the end. So when we're looking at storage vMotion, we're primarily concerned about synchronizing the blocks of the data stores, right? The VMDKs that are associated with it. In this case, what we need to do is synchronize the memory contents. Of course, that's generally a much higher volume, and that would typically be something that's a lot more dynamic potentially than the storage as well. So what we have to do is copy the state information for that virtual machine, or however many virtual machines we're going to vMotion, from that host over to another host. The exact same memory layout is really only going to work on another host with really quite similar hardware. But anyway, we'll take that register, the CPU registers and their memory layout and the stack and the frames and all the things that go into the CPU architecture, and we're going to copy that out to the other host. After we've copied a piece of data, it could very well be modified. So using the same sort of mechanisms that a virtual memory manager does, it'll maintain a dirty page list, and it's able to pretty easily tell that a particular block that had already been copied needs to be copied again because it's been changed. So it'll do that, and no problem. Hopefully at some point we can stabilize the transfer enough that we can reliably hand over control. That may or may not ever happen. We'll talk about that in a minute. But we also have the various network connections as well that get copied over, the different port states, and the mappings and so on and everything, so connections will not actually get lost. The only thing really that has to happen is that the transfer of control, we need to tell the switches that the MAC address that they had potentially learned was on one network interface is now somewhere else, which is about the same level of impact of, taking a network cable out of a physical server and plugging it into one switch port over or something like that, which should be negligible, and with TCP, everything should recover reasonably well. If you're using UDP-based protocols, you'll drop some packets, but this should be relatively minimal. Generally around the, 1 ping mark. I mean, that's not too bad overall. So to do this, and it's, so it's sort of a magical feature, but there is some science behind it. What we need to do is have hosts compatible with each other, and that really means that the CPU architecture has to be very similar. So if you want to go from a CPU to, a CPU of another vendor, so you want to take an Intel hardware CPU on the host, move a virtual machine that has organized itself for an Intel CPU and move it over to another host running an AMD CPU, forget it. It just will not do it. The instruction sets are relatively compatible between the two, but they're not exactly the same implementation, and the memory layout on an AMD versus an Intel system is not identical. Now, if it's the same CPU and it's the exact same CPU in the other system, hey, no problem. That's great. That's easy to synchronize, right? In other cases, let's see what happens. So if I want to take from an old CPU to a newer model CPU of the same vendor at least, we should generally be able to do that. Backwards compatibility and such. We're typically adding features to the CPUs, and that shouldn't really change the entire memory architecture and layout of the entire CPU. So that's usually okay. Going the reverse, usually not okay. So if I want to go from a newer CPU to an older CPU, and the virtual machine has been made aware of all these different features available on the CPU, they're going to have memory registers and things that reference it, and those are just not going to exist on the other hardware. So going from new CPU to an old CPU is not okay unless we're running the new CPU in compatibility mode with the old CPU. There's a few different ways to handle this. You could manually go in and specify different masks and so on in the host configuration. You could say, okay, well, you have these extra new features, but please go in at the register level and disable them. Good luck with that. I guess it's theoretically possible, but don't email me and ask me how to do it. So if you are running hosts as part of a cluster, we can enable something called enhanced vMotion compatibility. And on the cluster, when the nodes join, it will actually set those appropriate masks to whatever level you specify. And if a host tries to join the cluster without a CPU that's compatible with those modes that you've defined, they won't be able to join at all. If they are compatible with it, they'll set that compatibility and then join. Now, in terms of your network dependencies, we really should be isolating our vMotion traffic, like all of our management traffic, but especially our vMotion traffic, we should be isolating for a couple of reasons. It's not encrypted and it has memory contents, so there's any data that server is handling, any user data, as well as any system data, as well as things like encryption keys, could potentially be accessed. So we definitely need to isolate it from a security perspective, but vMotion is also very bandwidth intensive. And if we're not able to get a very good transfer rate of the memory pages between our hosts, vMotion may actually fail and not be able to achieve a steady state across the two hosts. So that having been said, even if you dedicate one network interface to it, we may actually want to dedicate multiple network interfaces to it. And this is definitely going to allow us to do more vMotions, but not necessarily as many as you might think. So we'll talk about that more in a minute. But anyway, we would set up one or more, or two or more, I suppose, if you're going to do multiples, VM kernel adapters that are able to communicate between the hosts. And basically, we don't use the load balancing and NIC teaming features and things that we would normally get. But we'll set up a vSwitch with a single uplink. We'll put a VM kernel adapter on it, and then we'll have it communicate with the host on that particular interface. Basically the same thing that we talked about when we did the iSCSI multipathing in the storage videos. So from a virtual machine perspective, if you want to do this, there's a couple of things that will have to happen. The CPU information about the host is made visible to virtual machines, and that's a level of virtualization that VMware doesn't really provide. You'd be getting more into emulation than virtualization. So assuming all the CPU dependency issues that we talked about a second ago are dealt with, there are a few things to be aware of. The network that the VM is connected to has to exist on the other host. The same port group name, the same port group options have to be set on both. Remember, we're going to transfer network connections and everything, and if you have a totally different NIC teaming model, then the whole thing may just collapse. So the port group and the options have to match. You can't have any locally attached devices, so any CD or DVDs that you have associated with the host, either something in the data store on a host, as opposed to a shared data store, or the host device itself, the CD and DVD physically in it, USB, serial, parallel ports. If you've done any CPU masking to assign specifically to say CPU 0 on a specific host, the other host should have a CPU 0, but whatever, it's not going to let you vMotion it. They just don't. Things like direct path, where we've assigned a specific I/O adapter inside the host to a virtual machine, even if that same exact type of adapter exists on the other host, you will not be able to vMotion it. You can shut the virtual machine down, you can do a cold migration, then you can boot it up on the other system, so you can migrate it, but you can't migrate it live. And also any raw device mappings where we've presented a LUN from the SAN directly to a virtual machine. Again, even though the other host may have access to all of those paths, it will not let you vMotion a machine with raw device mappings. If you put a local swap file on the machine, that does not necessarily cause us a problem, however. So when you go to configure swap for a virtual machine, you have the option to say store it with the virtual machine, which if the virtual machine is on shared storage, the swap will also be on that shared storage, or to use the local swap data store of the host where the virtual machine is running. If you do that, it will be able to be vMotioned. It's just that the vMotion will copy the swap contents along with the other physical memory contents, which might be more data than you would get otherwise if you had a lot of swap, but not necessarily a lot of actual memory content. If the swap is on shared storage, it doesn't need to be copied at all because the other host has access to it. But if it's on local storage, it will get copied as part of vMotion. But all this other stuff, you have to make sure that people do not leave that. If they need to use it, that they don't leave it on those virtual machines. Bad enough if you're going to manually do your vMotions, very, very bad if you're going to do DRS and you want to use automation to do vMotion when it's necessary for performance. You don't want to have anything that's going to prevent that from happening. So as for simultaneous vMotion, yes, depending on the number of network interfaces you have, depending on their speed, and depending on how many vMotions you're trying to do all at the same time, you have the ability to do multiple vMotions up to a certain point. And effectively, it becomes about 8 machines max. 8 virtual machines being vMotioned at once. So there is a whole cost model associated with this in terms of the host operations as well as the data store operations. That's something to point out as well. It's one thing to say that the host can do 8 at a time, but if I have many hosts, the data store can only do 8 at a time as well. And if I have multiple hosts using that data store, then that might be more of a bottleneck than the host limit itself. But even to get to the 8 max host vMotion operations simultaneously, you can see, for example, if I have a 100 meg network connection between my vMotion hosts, I can only do 2 vMotions across a 100 meg network link. So it's going to take me, at least a 1 gig link. Actually, really, at least 2 1 gig links, or potentially even 4 100 meg links to be able to actually do the 8 max vMotions that a host can support. On the other hand, it would only take me 2 1 gig links to be able to do it. But if I boost up to a 10 gig link or multiple 10 gig links or multiple 40 gig links, okay, well, that one link can handle up to 8, but the host will still only do 8 no matter how many 10 gigabit links I provide to it. So your magic number here is 8. And just be aware of that you will potentially need to provide enough resources to be able to get to 8, but that's about what you're going to get. So the other thing you may run into is the desire to run vMotion to a host that's in another data center. And this can work, and it's relatively new anyway in vSphere, but we have the ability now to do long-distance vMotion across routed links with up to 150 milliseconds of latency, which is pretty high latency, but certainly is not what you would see on a satellite link or something like that. So, I mean, as long as we keep it realistic and down to earth, pun somewhat intended, then we should be able to deal with 150 milliseconds latency. That's a pretty good amount for terrestrial links. So you can go across vSwitches, across vCenters even, if there's a whole other vCenter, although they're going to have to all be linked together. And this is an Enterprise Plus only feature. You're going to have to set up the provisioning TCP/IP stack to be able to do it. This is not shared storage based, so the performance of it is not necessarily going to be very high, and we're going to be having to transfer all of the storage along with all the memory content. If you want to do this, there's more detail available on it in the VMware KB 2106949. You can also use multiple networks for vMotion across long distance as well. So in order to get this set up, you're going to have to configure the provisioning TCP/IP stack if you want to do long distance vMotion. But using local vMotion, we also are going to be using the vMotion TCP/IP stack that exists by default. So we'll see setting this up in the demo. But effectively, we can set a different default gateway, a different set of DNS servers on that particular TCP/IP stack, and this avoids the need to go into the console and set up a whole bunch of static routes and things. So in the demo, we're going to take a look at setting up networking for vMotion. We'll talk a little bit about the TCP/IP stacks, and then we'll actually perform a vMotion, which is really very simple to do. But as we saw, there's quite a few things to be aware of and to plan for to make sure that it will work smoothly for you. So I'm in the vSphere web client looking at the hosts and clusters view, And if I right click on a virtual machine that's not running, in this case, my new Tiny Linux virtual machine, and we choose migrate, then you'll see we've got a few options available to us. All right, so in the migration options, you can see I've got the option to just choose the compute resource, which would be a vMotion, just change the storage would be a storage vMotion, or in this case, I can do both. Okay, so I'll select the alternate server. It's currently running on ESXi 6.1, so I'll select 6.2. And it says, okay, sure, there's no compatibility problems here. I mean, my virtual machine's not running, so I don't need to meet any kind of vMotion compatibility requirement. And then I'll select the data store that it's going to go on to, and then choose how to map my networks. Now, this is something I can do in a cold migration that I can't do in a vMotion. In vMotion, it really needs that other network to already be there, already be configured with a compatible configuration and the same naming. So this is a very small VM, so it really shouldn't take very much to migrate it. And you can see that it appears pretty quickly on ESXi 6.2, and I can then proceed to start it up. So cold migration is easy, but it's not very exciting compared to doing that live with vMotion, which we'll see shortly. And if we scroll down, we can see under related objects that it's now associated with our ESXi 6.2. The data store that I selected is now the data store one of the other host. And really, they should be named better. I wish those data stores got named data store and then the host name, but they don't do that for some reason. So as for performing a real vMotion, which is, the migration of a live machine, let's take a look. If I right click on the virtual machine and select migrate, I'm not really ready to do a compute vMotion yet, but there's really not much dependencies for a storage vMotion. So I'm going to say in this case, I just want to change the storage. And if I click next, you can see that I can pretty easily go in and select another data store that's associated with my host. And then I can specify again whether I want to keep it as a thin or thick or whatever, and go from there. Now, I choose thin provision for all of my labs. Keep in mind that there is performance overhead associated with thin provisioning, and it's not really always the best choice. Okay, so that migration will start. If I head back over to the home page, then we can take a look at the tasks view and see what's happening for it. I suppose if we want to prove that it is in fact actually running, then we can confirm that by opening the console. And if we want to set up vMotion, what we're going to need to do is get networking configured for it. We'll also need to make sure that our virtual machines are not introducing anything that's going to interfere with vMotion. So I'm going to head over and create everything that I need to do this, which effectively is a VM kernel network adapter, a switch to go with it, and then one or more interfaces as well. So I'm just going to go ahead and create a new standard vSwitch, and then assign it at least one adapter, but potentially multiple adapters and multiple VM kernel adapters to be able to support the maximum number of vMotions, depending on the cost limits associated with our host. So in this case, I've also gone in and specified that I'm going to use the vMotion TCP/IP stack, which is definitely recommended and is now a default. Previously, you used to be able to create additional TCP/IP stacks, but there were none available by default. So I'm just going to go ahead and assign a basic IP address on that subnet and a basic mask. And I've got one NIC associated with it. And then I'll do really the exact same thing on the other host. And our port groups have to be the same. So the vSwitch has to be not exactly the same number or whatever, but the vSwitch has to have a compatible number of uplinks. Things like the port group and security and other settings all need to be the same. The port groups need to be defined the same. Of course, the easiest way to make all this happen is to use the distributed vSwitch. But for my purposes, this will work just fine. So I've got a VM kernel interface. I've enabled it for vMotion. I'm optionally using the vMotion TCP/IP stack, and I can go in and set whatever additional properties I might need. But you can see that it's enabled for vMotion traffic, and that's the key. So once I have the networking configured appropriately on both hosts, then I can go ahead and try to do either a compute resource only vMotion or a compute plus storage vMotion. So I'll expand my data center and then select the data store that I want. I mean, I've got a couple of options. I could choose the data store first, then the host, or the host, then the data store. Not really that much of a difference. So even though I've configured the networking correctly, you can see it's still telling me, well, you've got this ISO image that's associated with this virtual machine. It's on local storage. I'm not able to migrate it. You might hope that it would just disconnect all of those things automatically, but it doesn't. So let's just quickly go into the settings of that virtual machine and remove it. So I'm just going to right click, go to edit settings, and then under the CD DVD options, I'll remove it. And I suppose I could redirect it back to one of the client or host devices. I could just disconnect it, but I believe it will still give me a warning if I do that. It's only a warning though, I could ignore it. Like so many warnings I have previously. So, okay, so that should do it. And let's see what we get now as an option. So I'll just go back and again, choose the same options. I want to change the compute and the storage resource. Told to choose storage first. I'll pick the data store associated with my other host. And that should pretty much get us the host that we want, of course, too. Although again, I might well be doing this with shared storage already anyway, so could be a little different there too. All right, so we can see it's now telling me that ESXi 6.2 is ready to receive vMotion operations or vMotion transfers. So I'm going to go ahead and select the network that I need to map, which is totally fine here. And it says, do I want to schedule that with high priority or with regular priority? So with high priority, certain virtual machines might go ahead in the queue if there's more virtual machines available than slots to actually do the transfers. Then those will go first. And also that may have more of a performance impact on the host that it's getting transferred to. So while that's in progress, again, let's launch the remote console and make sure that the virtual machine is still responding. And we can see that it is responding. So let's go back over to the home and monitor that task and see what the progress is. All right, so we can see it's in the process of relocating the virtual machine. That is, in this case, a storage and host operation, so this could take a bit of time. But we can see that the VM continues to respond, and then we can focus on various ways to make that vMotion go faster, primarily by giving it faster network interfaces to transfer across. So once again, through the magic of editing, I think we can make this go a little bit faster. And so now that it's complete, you can see that the VM is up and running on ESXi 6.2 in this case. And once again, we can get on the console to make sure that that's actually happening. It did happen, and had we been doing like a continuous ping against it, probably would have seen something along the lines of one missed ping. So in summary, vMotion is a fantastic feature, but you absolutely should isolate its traffic onto its own dedicated network. Across multiple sites, there's other security considerations that you should also take into account. As for doing it, as you saw, it's really quite easy, but you need to make sure that people maintain proper discipline when creating and managing virtual machines, that they don't assign any local resources, or at least they don't leave any local resources assigned when they go to try and vMotion the virtual machines. So in the next video, we'll talk about high availability and fault tolerance, where we can have vSphere either recover a virtual machine in the event of a failure, or avoid failures in the first place by running virtual machines in more than one place at the same time.